Good evening, everyone.
Good evening, sir.
ఇరగొడతారమ్మా దాన్ని తీసుకో. Good evening, everyone.
Good evening, sir.
So
Good
today
evening, sir.
we discuss a known topic. What are the things we are discussing which already known? Remainder theorem, which is applicable for, which is applied for polynomials, division algorithm for polynomials. Anyone from the first topic or your previous topics, how many of people know how to divide an equation with another equation and what is the condition required? Suppose I'm sharing the screen, guys. We are going to discuss division algorithm for polynomials today. Guys, 1 second. Meanwhile, think over the condition. What is the condition to divide an equation with another equation? And what is the division algorithm for numbers? Anything? Yes, ma'am. Yeah, fine. தெரியும் கார்த்திக் லட்சுமி தானா? சொல்லுங்க மேம். கிளாஸ் போயிட்டு இருக்காரு, அதான் நார்மலா பேசுறீங்க வீட்டுல போட்டு. கிளாஸ் ஒன்று போயிட்டு இருக்கு. வரல, சொல்லுங்க. எனிதிங் ஜெனரல் ஆர் ஜெனரல்? I saw your missed call. Most of the time the mobile is with my daughter or son. Adukada I didn't see. Now after I woke up, I'm having classes. I thought I will call you in the evening. I think you are also busy with your son now. Oh. Online school. They are paying properly. Then it is good. Many schools are not paying properly. That's what my friends and many people are telling. Why? Sorry, guys. Yeah, this we are discussing. I gave a question. What is the condition to divide an equations with another equation, or what is the division algorithm? What is the division algorithm for numbers, man? Anyone can able to recollect the division algorithm for the numbers? That is only equal to division lemma, no? Guys, anyone? No answer?
Dividend is equal to divisor into quotient plus remainder.
Dividend will be equal to divisor into quotient
Quotient plus remainder.
remainder. See, if I see the dividend is always greater than these three values. Am I right? Suppose if I am telling A is equal to B into C plus R, B, C, R is always less than A only now. In case of numbers.
Yes, sir.
If I am taking 10 by 6, 10 by 6 can be written as how? 10 is equal to 6 into 1 plus 4, correct?
Yes, sir.
This is your quotient, this is your divisor, this is your remainder, this is your dividend. Same as if I am taking a polynomial P of x by Q of x, what is the minimum condition to divide these polynomials? What is the minimum condition required? What is the minimum condition? Any equation I can divide with any other equation? Is it possible? Is it possible I can divide a proper division 6 by 10? Is it possible I can apply the remainder theorem? 6 is equal to 10 into some real, some integer, sorry, some natural number plus remainder, where R is
No,
also
sir.
a natural number. Like us, if I am dividing P of x with Q of x, where your P of x is like dividend, Q of x is like divisor. So the index of P of x must be greater than or equal to index of Q of x. Got it? What I am trying to say? The index means highest power of the polynomial. The degree of the polynomial, I can say. Instead of if you are confusing, the degree of P of x must be greater than or equal to degree of P of x. If I am having anything like that, I can write P of x will be equal to Q of x into R of x, and this can be taken as some h of x, where P of x is dividend, P of x is divisor, h of x is quotient, or Q of x I can take, capital Q of x, and R of x is remainder. Got it? This is only division algorithm for polynomials. How many people know in the class how to divide an equation with another equation? Suppose if I am giving a polynomial, how many people know? Suppose if I am giving a question, so remainder theorem, I am writing the remainder theorem first, the statement of the remainder theorem. Everyone knows remainder theorem for numbers same as remainder theorem for the polynomials. What is the remainder theorem for the numbers? If f of x is a polynomial in x divided by is divided by x minus a, then the remainder is f of a. This is called remainder theorem. So before going to the remainder theorem, we will do some basic numericals how to divide an equation with another equation. How many people know how to divide an equation with another equation, guys? Is it are you done in grade 9?
Yes, sir.
Yes.
So I can give a simple equations. I can find the remainder f of x is equal to x square minus 5x plus 8 by x minus 2. Do this question, guys.
Two, sir.
2. Any others? One more question. F of x is equal to 6x square minus 21x plus 71 by x plus 3. What method you are using to calculate the remainder, guys?
So finding the x and then substituting it in the value of x.
So that is only remainder theorem. That's what we done in grade 9. Am I right?
Yes, sir.
So now we are coming back to the division algorithm for the polynomials. So if I am using the log division method also, you have to get the same thing. Am I right?
Yes.
So anyone, I am trying with long division method. So 6x square minus 21x plus 71. I am using long division method x plus 3. So what I will get here? First I am using 6x square by x. This is 6x. This is 6x square plus 18x. So minus plus minus, this is 20, 30, 39, minus 39x plus 71, minus 39x by x, so minus 39, this will be minus 39x minus 39 into 3, how much? 90, 27, 117. I'm adding, this will give how much? 117 plus 71. 188. What is the remainder in this case? Is it right? 188 is right answer. Is 188 is right answer? Guys,
Yes, sir.
we are here. No one is replying. See, first of all, I am dividing. This is a polynomial of degree 2. If I am considering this is one polynomial of p of x, I'm dividing with another polynomial of q of x. I'm getting another polynomial of some f of x I'm taking. That remainder is some r of x. Sometimes it might be an expressions also, we can't say. But q of x and f of x degrees is always less than p of x. So division algorithm for how we are using for numbers, same way p of x can be written as q of x into f of x plus r of x. If r of x is 0, then I can say q of x and f of x are factors of the p of x. Got it what I'm saying? If the remainder is 0, quotient and divisor will be the factors of the dividend.
Yes, sir.
Yes, sir.
So if I'm taking the numbers what it says, what is the division algorithm in the number says? Dividend will be equal to divisor into quotient
Just reminder.
plus remainder. If the remainder is 0, divisor and quotient are factors of the dividend, correct? Suppose if I am taking this is p of x, this is q of x, and this is f of x, and this will be r of x. If r of x is 0, I can say q of x and f of x is factors of p of x. Instead of that, if I am saying q of p of x, what it means? What it means according to division algorithm? What it means? It should not leave any remainder, correct? It should not leave any remainder, am I right?
Yes, sir.
Now, if I am giving an expression 2x square plus 3x plus 1 and x plus 2 without long division method, how I can say x plus 2 is a factor of this p of x? What theorem I have to use?
Reminder theorem.
Yeah, using remainder theorem. Calculate remainder. If the remainder is 0, I can say x plus 2 is a factor. Check whether x plus 2 is a factor or not. Check whether x plus 2 is a factor or not without long division method. No. What is the remainder is
No,
leaving?
sir.
What is the remainder here?
So it's 3.
3. Correct? So, how we can define p of x is equals f of x into q of x plus r of x, and degree of r of x, q of x and g of x is always less than the p of x, or I can say the degree of the remainder is always less than the g of x and f of x. See, our topic is completely dealing with if I am giving one factor or one zeros. Suppose if it is a cubic equation, how many zeros? Suppose if it is a cubic
3.
3. If it is a power 4 equation, how many zeros?
4.
So 4. Now this remainder theorem you are using to calculate the unknown factors of the polynomial. Suppose if I am giving one factor or two factors of a polynomial or 1 0 or 2 zeros of the polynomial, how to calculate remaining? So find all the zeros of polynomial. Find all the zeros of the polynomial 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. If we know 2 of its zeros, 2 of its zeros are root 2 and minus root 2. That means if I am substituting x is equal to root 2, my p of x is 0. If I am substituting x is equal to minus root 2, p of x is 0. In that means x minus root 2 is a factor of p of x. X plus root 2 also is a factor of p of x. Suppose if I am having a number 24, this 24 can be written as 2 into 2 into 3 into 2. I can say 4 into 6 or 4 into 3. The product of two factors is also a factor of 24. Got it what I am saying?
Yes, sir.
2 is a factor, 3 is a factor, 4 is a factor, and 6 is a factor, 12 is a factor. You can take 3 and 4. The product of 3 and 4 is also a factor. Product of 2 and 3 is also a factor. 6 and 12, I can't say, but the numbers, the product of the two factors which is less than 24, I can say a factor of that. Same as here also, if these two polynomials are factors of the given polynomial, the product of this also should be a factor because it is a linear polynomial. Linear polynomial, it will use a quadratic, but given is biquadratic. So x minus root 2 into x plus root 2 is a factor of p of x. So what is the value of x minus root 2 into x plus root 2? X square minus 2 is a factor. If x minus 2 is a factor, and find out the remaining factor. Find out the remaining factor. So you have to use the long division method. 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. And to calculate the remaining factor, what we will do? Whatever the factor I am having, I am dividing with that factor. So whatever the answer I am getting, if the remainder is 0, then I can say the quotient is the factor of the given polynomial. Correct or not? Suppose if I am giving 24, if I am asking you to divide with 6, whatever the number I am getting, the answer is also a factor if the remainder is 0. Same as I already know x square minus 2 is a factor, and which will use the remainder if I am dividing with the p of x with this given factor. What are the quotient I am getting? That is a division algorithm says. If the remainder is 0, quotient, dividend are factors of the given number. Correct or not? Got it? What is the purpose of the remainder theorem here? Guys, anything confusing?
No, sir.
No, sir.
Let me know how to calculate the remainder. sorry, quotient here. 2x power 4 by x square. This will be 2x square. 2x square into x square is 2x power 4 minus, you won't get 0. This is 0x cube, because this can be written as x square plus 0x minus 2. Then it will be easy for us to calculate. Minus 4x square. I am subtracting 0 minus 3x cube minus 3 plus 4 is plus x square plus 6x minus 2 minus 3x cube by 2x square. Sorry, it's x square only, not 2x square. Minus 3x minus 3x cube plus 0x square minus of minus plus 6x minus 2 is equal to 0. No, don't come, sorry. This will be 0 x square plus 0 minus 2 plus 1. This is x square minus 2, the subtraction is 0. So, what is the quotient here? 2x square.
2x square minus 3x plus 1.
If it is able to factorize, how you will know is it can able to factorize? So the given p of x can be written as x square minus 2 into 2x square minus 3x plus 1. So we know how to factorize x square minus 2. So can you able to factorize the given equation, this equation, using the previous concept? How to factorize this one, splitting the middle term? Correct or not?
Yes, sir.
2x square minus 2x minus x plus 1. If I am taking 2x common, x minus 1. If I am taking plus 1 common, sorry, minus 1 common, x minus 1. So x minus 1 into 2x minus 1. So x is equal to 1 comma plus 1 by 2 are the remaining zeros of the polynomial. Suppose if you are unable to factorize, then I can say these are the factors. It is having only two real zeros and remaining are unreal zeros. This is how we can able to do remaining zeros of the given polynomial using the remainder theorem as well as division algorithm. Is it clear, guys? Only the thing is there are only two steps. One is divide with the given polynomial. If they are not mentioned, it is a factor. Check whether it is a factor or not. Verification of factor can be calculated using the remainder theorem. If they are not mentioned, we can able to solve whether it is a factor or not using the remainder theorem. If it is a factor, divide it, whatever the expression you are getting, again you factorize. Shall I go for the numericals?
Yes, sir.
Yes, sir.
It's very simple. The numericals are divide the polynomial p of x by the polynomial g of x and find the coefficient and remainder. How to do? The first three questions can you able to do? I need answers. I am asking you to solve by your own, because it is known thing only. Correct? Is there any new thing here? After completion of this exercise, I will give some questions little bit advanced to this topic related to this only. But what we can learn other than this, that I will teach you. Let me complete this topic first. What is the first one answer? Anyone got the first one? X cube minus 3x square plus 5x minus 3 x square plus 0x minus 2. We are taking x
So
cube.
quotient is x minus 3 and the remainder is 7x
7x
9.
minus 9.
Done which method?
So long division.
Long division.
Is there any possibility without long division? Suppose the same question, if I am giving 1 mark and as MCQ, how we will do? What is the answer? You said
X minus 3 is the quotient and 7x minus 9 is the remainder.
this quotient. This is
And
remainder.
remainder is 7x minus
7x minus 9 is the remainder.
9. Yes, sir.
Yeah. Is there any particular method? Is it possible to calculate remainder without long division method? We'll discuss after the end of the topic. If there is any, we will explore it. Yes. Next question. X power 4 minus 3x square plus 4x plus 5. X square minus x plus 1. Order of the terms is very much important. Please solve and let me know what are the quotient and remainder. Yes, anyone got the answer? x cube plus x square. So this will be minus plus minus 0 plus x cube minus 3 minus 4x square plus 4x plus y. Next one is plus x. We're taking x cube minus x square plus x plus 0. Minus plus minus. Minus 3x square plus 3x plus y. Minus 3. Minus 3x square plus 3x minus 3. Is our right answer? Is this right answer, guys?
Yes, sir.
What about the third question?
1 minute, sir.
Yeah. X power 4 plus 0x cube plus 0x square pen better sila dulu. Right ayam bite ఉండొచ్చు. వంటింట్లో ఉంది ఒకటి తెల్ల తెస్తాను. అసలు ఇయ్యట్లేదు ఏడుంటుంది. అమ్మాయి పడుతుంది. అయ్యో మొత్తం నీళ్ళు Guys, anyone got the third answer?
The quotient is minus x square minus 2.
Minus x square minus 2.
Yes, sir.
Let's see, minus x square, if I am taking minus into minus x power 4 plus 0x cube minus 2x square minus plus, straight away I am getting 2x square minus 5x plus 6. So I am
So
taking
the remainder is minus 5x plus 10.
minus 2 now. Is it right? Quotient is x minus x
Yes.
square. No. Minus of minus plus 2x square plus 0x minus 4 minus plus. What is the remainder, madam?
So minus 5x plus 10.
Correct. This is quotient, this is remainder. Next question is related to remainder theorem. Just he is asking us to verify whether the given polynomial is a factor of another polynomial or not. We can do in two methods. One is long division method, second one is remainder theorem. But how to do using the remainder theorem? Long division method is simple. If we found the remainder is 0, but how to use the long division method? Long division method is easy here. Even remainder theorem also you can say t square minus 3 can be written as t minus root 3 t plus root 3. Substitute the root 3 in the given polynomial. If you are getting 0, then it is a factor. Substitute minus root 3 also in the given polynomial. You have to get the remainder is 0. That means if I am saying a, b are the factors, that means a should be divided with the factor and given number, and b also should divide with the given number. Then only I can say a into b can be divided with another number. Will you able to remember when you are in lower classes, condition for divisibility for 6. If any number can able to divide with 2, 3, then it can able to divide with 6. Same concept, but it is little bit hectic process. Better use the long division method. Check whether the given equations are factors of the second polynomial or not. Just you have to identify whether the remainder is 0 or not. Solve the 3 questions and let me know. Anyone done the first question? Two t power 4 plus 3t cube minus 2t square minus 9t minus 12. I am dividing with t square plus 0x minus 3. So t power 4 t square. So 2t square will come here. So this will
Sir,
be.
I've got the remainder as 0.
So this is a remainder is 0 here. Next. What is the quotient you are getting here?
Sir, plus 2t square plus 3t plus 4
Plus 2t square and
plus 3t
plus 3t
plus 4.
plus 4. Let's see. And 2 into 3 is minus 6t square. Minus plus. This is 3t cube minus 2 plus 6, 4t square minus 9t. 3t cube t square, 3t. 3t means 3t into t square. 3t cube plus 0t square minus 9t. Minus plus. This is 4t square plus 0 minus 12. 4t square by t square is 4 plus 4. 4t square plus 0 minus 12. Subtraction is 0. Correction. X. The conclusion is t square minus 3 is a factor of given polynomial. Simple. The second one, x square plus 3x plus 1. Even you can do in this method also. X square plus 3x plus 1 can be written as x square plus 2x plus x plus 1. No, I can't divide like this because there is no real factors for this. So straight away you have to use long division method. 3x power 4 plus 5x cube minus 7x square plus 2x plus 2 and dividing with x square plus 3x plus 1. 3x square 3x power 4 plus 9x cube plus 3x square. minus 0. 5 minus 9 is minus 4x cube. Minus 7 minus 3 is minus 10x square plus 2x. 4x cube minus 4x. Minus 4x cube minus 12x square minus 4x plus 0. 2x square plus 6x plus 2 plus 2. 2x square plus 6x plus 2 minus, the remainder is 0. So second one also remainder is 0.
Yes, sir.
Go to the third one. The remainder is 0. This is a quotient. The quotient is 3x square minus 4x plus 2. Next one, power 5 equation, x power 5 minus plus 0x power 4 minus 4x cube plus x square plus 3x plus 1. X cube plus 0x square minus 3x plus 1. Solve this one and let me know what is the quotient and remainder. Square. Is the remainder is 2?
Yes, sir.
Anyone got the remainder 2 or any different answer you got?
So reminder is 2. Reminder is 2.
Yeah. So let's go for the next question. Guys, I can move to the next question.
Yes, sir.
It's from others. About others. Done, guys. I will wait if you are not done.
Yes, sir. Done, sir.
3 questions remaining. That's it for this chapter itself. After that, we will go for like examination or some other worksheet questions. Guys, how to do the question number 3? How to do the question number 3? Like your example questions, what are the things we done in the beginning? They gave the two zeros. First, identify the polynomial using these two zeros. They gave the two zeros means obtain all other zeros. They gave the biquadratic equation. They are giving the two zeros, and they are saying x plus root of 5 by 3, x minus root of 5 by 3. Both are the factors. From here, x square minus 5 by 3 is a factor of given p of x. So now using the long division method, identify the quotient. Once you got the quotient, once I calculated the quotient, then it will be easy to calculate the remaining zeros. I'm expecting the answer from others. What is the quotient? Definitely you should get remainder is 0 because they given is these two are the factors. And the product of these two factors is another polynomial that is also factor for give p of x. So please divide and let me know what is the quotient and remainder you are getting. If you are getting remainder is 0, then it is right. Three x power 4 divided by x square. This will give 3x square. 3x square. 3x square into x square is 3x power 4 plus 0x cube minus 5 by 3x square. Somebody message. What is the quotient, guys? Guys, what is the quotient?
3x square plus 6x plus 3, sir.
6 plus 3.
Yes,
So
sir.
if I take 3 common, x square plus 2x plus 1. So this will be 3 into x plus 1 into x plus 1, correct? But you told somebody gave the answer 1 comma minus 1. Then it should be, if it is 1 comma minus 1, the quotient should be like x square minus 1. But I am getting x plus 1 whole square, x square plus 2x plus 1. 1 comma 1 are the remaining zeros, it is showing. Any others got the answer? Anything? Any others?
The
Plus
quotient is 3x square plus 6x plus 3.
3x square plus 6x plus 3. If it is like this is 3 into x plus 1 into x plus 1. Ma?
Yes, sir.
So the remaining roots are minus 1 comma minus 1. The remaining zeros are minus 1.
Yes, sir.
Yeah. Any others? I think I have to check the message one more time. Yes, minus 1 comma minus 1. Arman, correct. Any others got the answer? Guys, anyone, any others got the same answer, or I can solve here? Some response, guys, please.
Sir, minus 1 and minus 1 are the other zeros, sir.
Yeah. So other than this, we are having only 2 more numericals left. Along with this, I will bring some other numericals to solve in the next class. Maximum next 2 classes we will sit on more practice on different kind of questions and 2.4 optional exercise also, because some of the questions in optional exercise will be little bit challenging for us. We'll try to do some more questions related to this topic, some higher order thinking skills questions or some other questions. I will get the questions by next class. Shall I end up the class? Anyone having any doubts?
No, sir.
No, sir.
No, sir.
We'll meet in the next class. Just go through overall practice for tomorrow class. Bye everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.